All right, if you're working anywhere near industrial security, you've definitely heard of the industrial DMZ. I mean, for decades, it's been the go-to for separating the corporate network from the factory floor. But here's the thing. Our factories are getting way smarter, way more connected. And that traditional approach, well, it's starting to show its age. So today we're going to dig into why the game has totally changed and what the future of industrial network security really looks like.
So here's our game plan. First, we'll get the basics down, what an iDMZ is, and why that classic IT versus OT divide made it so necessary. Then we'll look at where that old-school perimeter model is starting to crack under pressure. After that, we get to the really cool part. We'll dive into new, more granular approaches like micro-DMZs, and we'll wrap it all up with a practical roadmap to help you start modernizing your own network.
Okay, so first things first, let's make sure we're all on the same page. What exactly is an industrial demilitarized zone, or iDMZ, and what's its whole purpose anyway?
The easiest way to think about an iDMZ is like a secure airlock between two completely different worlds. Its #1 job is to make sure there's absolutely no direct chit-chat between the corporate IT network and the industrial OT network. Everything, and I mean everything, has to be inspected and approved in this neutral zone before it can even think about passing through.
So, at its core, it's an extra layer of security that acts as a mandatory middleman. Any piece of data trying to get from the business side to the plant floor or back again has to stop in the iDMZ first. This basically creates a zero-trust environment by default. Nothing gets through unless you specifically said it's okay.
So, why go through all this trouble, right? Why can't these two networks just talk to each other? Well, it all comes down to a fundamental conflict in priorities. The IT and OT worlds, they just operate on completely different rules. Let's break that down.
On one side, you've got the IT world. It's all about protecting data. Confidentiality and integrity are king. It's fast, it's dynamic, hardware gets refreshed every 3 to 5 years. A quick reboot for a security patch, not just a regular Tuesday. But then you look at the OT world, and the absolute #1 priority is keeping the physical production line up and running, safely and reliably. A reboot there isn't just an inconvenience. It could mean thousands of dollars in lost production. We're talking about machines that could be 20 years old, running ancient software that you just can't patch. They really are two different universes with completely opposite goals.
And look, this separation isn't just some good idea someone had. It's actually a core principle in major security standards like IEC 62443. That standard is all about creating what it calls zones and conduits, which is just a formal way of saying you need to build clear, secure boundaries between different parts of your operation. And that's exactly what the iDMZ is designed to do.
So for a long time, this big central iDMZ was the answer. It was our fortress wall. But today, with all the demands for more data, for remote access, for cloud connections, that wall is starting to get some serious cracks. Let's talk about those challenges.
You know, this quote from Tripwire just hits the nail on the head. One of the biggest problems is that because the iDMZ sits right between IT and OT, it often becomes this orphan zone. The OT team thinks it's IT's problem, and the IT team, who's already swamped, assumes OT is handling it. This no man's land turns into a huge, dangerous blind spot for security.
And the headaches just keep coming. This classic model creates a massive bottleneck. All your data has to squeeze through this one single point. Need to add a new production line or connect a new cloud service? That usually means a complicated and expensive network redesign. And let's be honest, when a vendor needs urgent remote access to fix a machine at 2 a.m., how often does a temporary hole get punched right through the perimeter, bypassing the iDMZ altogether? It's a rigid solution that's just not built for today's flexible world.
Okay, so we've laid out the problem. The old fortress model is brittle. So, what's the answer? Well, it really starts with a big shift in how we think about this. Instead of one giant wall around the whole factory, we need to start moving security controls a lot closer to the actual things we're trying to protect. This is that classic model, right? You have a strong border between IT and OT. But the dangerous part is that once an attacker gets past that one main gate, the internal OT network is often completely flat. And what that means is there are very few internal controls. An attacker can move around freely inside, and that's a massive risk to production.
And this brings us to a really important idea: micro-segmentation. Instead of having one big, open network on the factory floor, you break it up into smaller, isolated zones. It's kind of like adding locked doors and security checkpoints inside the building, instead of just relying on the security guard at the front gate. That way, if one area gets compromised, the threat is contained right there and can't spread to the whole plant.
Okay, now let's take that concept one step further. What's the really modern alternative, especially if you're a mid-sized manufacturer dealing with old equipment, a tight budget, and you just don't have time for a massive network overhaul? This is where the whole idea of micro-DMZs really starts to shine.
So here's the game-changing idea. Instead of one big, expensive physical iDMZ, you create a tiny, software-defined micro-iDMZ for each and every one of your critical assets. Imagine every important controller or PLC on your production line getting its own personal, dedicated security guard. This is usually done with something called an overlay network, which is basically a virtual network you build right on top of your existing physical one. You get to add all this security without changing a single wire.
And the benefits here, especially for manufacturers, are just huge. Because it's an overlay, you don't have to rip and replace your current network. That means no rewiring, and most importantly, no downtime. You can finally protect that vulnerable old machine that you know you can't patch, extending its life and saving you from a really expensive upgrade. This is exactly the space where companies like Trout are building lightweight tools to make this approach simple, practical, and affordable, letting you modernize your security one step at a time.
Now, this all sounds pretty great in theory, but how do you actually make it happen, right? It's not about flipping some magic switch overnight. It's about following a practical, step-by-step roadmap.
It all starts with the basics. You gotta map your assets and really understand how data is flowing around. Then you design these small, secure bubbles, or enclaves, for your most critical systems. Now here's the key. You deploy this incrementally as a software layer right on top of what you already have. There's no big bang project, no shutting down production. Over time, you can shift from old-school network rules to more modern identity-based controls, and just keep an eye on things and tighten the rules as you go. This turns modernization from a giant disruptive headache into a manageable journey. So, if there's one thing to take away from all this, it's that the old model of a single, static wall just isn't cutting it anymore. The future of industrial security looks a lot more like a dynamic, intelligent web of controls that protects each asset individually. Which leaves me with one final question for you to think about. When you look at your own network, is your security perimeter a brittle wall, or is it a resilient web